to CHI-NY. With me today is Professor Naba Mondal from the Department of High Energy Physics at the IFR, where he's been working on detecting all kinds of elementary particles over the last more than 30 years. And he'll be telling us about the Particle Hunter's Guide at the next CHI-NY session. So, Naba, why do we want to detect particles, and what kind of particles are these?
Well, as you know, everything is made out of tiny particles. For example, the atom is made out of electrons and the neutrons and protons in the nucleus. So these are all tiny particles. And to understand how all the matters interact with each other, or even how whole universe has been evolved, we want to understand how the particles interact with each other, what's their properties, how they interact. So that is why we want to understand and detect all sorts of particles that are there in the universe.
And which are the most difficult particles to detect?
Well, there are some which are easy, like electrons and protons and so on, but there are also some particles which are very difficult. The most difficult particles are those which doesn't have any charge, for example, because to detect particles, the particle has to interact and do something in the medium so that you can pick up that signal. And these neutral particles doesn't interact easily, so it is very difficult to detect them. And especially difficult is what we call the neutrinos. They don't even interact at all, or very little, and so they are what we call the very psi particles. Detecting them is very difficult.
And we are building a large setup to detect neutrinos at the India-based Neutrino observatory, and behind us is some sort of a test structure for this?
Yeah. So actually, this what you are seeing here is called a stack of resistive plate chamber detector. These are also a kind of particle detector. There are many different kinds of particle detectors, and we have chosen this one because they are easy to build and also cheaper. And to detect neutrinos, you need a huge detector. As I told you earlier, the neutrinos hardly interact, and because of that we have to have a huge detector. How big? Something like 50 kilotons. So you will have, what you are seeing behind them is only 12 such detectors, and we have to build 30,000 of those particle detectors for detecting neutrinos in India-based Neutrino observatory.
So to find out more about that, do come for the CHI-NY session. It promises to be exciting, and we'll show you how you detect all kinds of particles. See you there.